Welcome back to Believers Eyes Academy. In today's topic of the day discussion, we will be discussing about the blood moon. As we all know, the entire world witnessed the total lunar eclipse on the 7th September night, and it was a once in a lifetime opportunity which kind of definitely has created memories for all of the people who have watched it. And also for the UPSC aspirant, it is important to know the reason behind the occurrence of the blood moon, and also from the examination point of view it is also important to understand the way or what is the process behind the formation of the total lunar eclipse or the blood moon. So today's video is on understanding what a blood moon is. So a blood moon is the dramatic red glow of the moon seen during a total lunar eclipse. It occurs when Earth comes directly between the sun and the moon, casting its shadow, and instead of turning completely dark, because when the moon, or let's say when the Earth is between the moon and the sun, it actually has to make sure that the moon is completely covered in dark, right, because of the Earth's shadow. But on the contrary, the moon appears red, orange, or copper colored. So hence the name blood moon has been given to the reddish hue which is formed on the moon as a part of the reflection or the reflected light. So of course these are all the things that you time and again read through, but let's understand practically as to what or how this forms, right? So we discussed that there are three important things which comes into the play. So one is three important aspect. One is the sun, and then earth, and as we all know, earth comes in between the sun and the moon. So we have the earth, and now we have the moon. So this is the exact positioning of these three things, especially the sun, earth, moon, during a total lunar eclipse. And we know that earth doesn't actually come in between, it is basically the moon, because if we see the orbit of the moon revolves around the earth. So this is the orbit of the moon. And now, considering this is the reflection or the light from the sun, we can categorize this as two different things, because when we're talking about total lunar eclipse, there are few technical definitions to it. So one simple way to understand or to define lunar eclipse in layman terms is to tell that when earth comes in between the sun and moon, right, we can say that the moon is completely eclipsed, the lunar eclipsed. So what should generally happen? Because the earth is completely coming in between, and or even before that, why does the moon appear white? Is the white or the moon white in color? No, it is the light reflected by the moon of the sun. It is the reflection of the sun's light on the moon to our eyes which makes us feel that the moon is white in color. So now when the earth comes in between the moon and the earth, generally what should happen? The moon should be dark. But on the contrary, the moon becomes red in color, right? So hence we call it the red moon or the blood moon. So now, why is it? Now, to understand this, we have to know two more important terms from the eclipse point of view. One is the umbra, next is the penumbra. So these are two imaginary areas in the space. So umbra, we can call it the darkest side or the darkest part of Earth's shadow. So when the moon passes exactly through the umbra region of the Earth's reflection, which is the darkest part of the Earth's shadow, because now the sun, or whatever the light is coming from the sun, the earth comes in between. So obviously the shadow zone of the earth, this is the complete shadow of the earth, which is completely dark, and that area is called as umbra. And then we have another area which is not that dark but has some light emitted from the sun's rays, right? So this is called as the penumbra. So now when the moon exactly passes through the umbra region of the earth's darkest part of the earth's shadow, we can call that the moon is completely eclipsed, or a complete lunar eclipse has occurred, right? So this phenomena is called as the total lunar eclipse. Of course, we will see as to why the color turns red. Of course, it is because of the scattering of light. One of the phenomena is the Rayleigh scattering, which we will study what that is. Even before that, let's understand that this lunar eclipse, the total lunar eclipse, usually happens 2 to 3 times a year, and this is one that we witnessed recently, right? So I hope what the lunar or the total lunar eclipse is clear from this part. You have to keep in mind the umbra, penumbra. Umbra is the darkest part of the earth's shadow. So when the moon, while taking its orbit, passes exactly through the umbra region of the earth's shadow, which is the darkest part of the earth's shadow, then you can call that the moon is eclipsed. So now, next question. If the moon is in the darkest side of the earth's shadow, then obviously the moon, obviously it is not reflecting the sun's light. Absolutely, there is no light from the sun which is directly falling on the moon, right? So it should be dark, but why does it appear red? Now, the phenomena here is the scattering of light, or also called as the Rayleigh effect, right? The Rayleigh scattering. So what happens? So as we know that sun has, what is the general color of sun? So depending on what time we see the sun, right? The sun has various color. For example, if we see the sun exactly in the noon, right? It appears to be white in color, right? Or bluish in color, right? Kind of white, right? And the same sun during the sunset or in the early morning, right? It looks either orangish or reddish, right? So it is the spectrum of light that we are talking about. So of course, when we talk about sunlight, right, has 7 different colors, right? The rainbow, right? All of those things. So all of these colors have different wavelengths, correct? They have different wavelengths. And what does the Rayleigh effect say? According to the Rayleigh's scattering phenomena, it says that the intensity of light scattered is inversely proportional let's write it here, because this is a very important concept to keep in mind, to know. So it says the scattering or the intensity of scattering of light is inversely proportional to the wavelengths of that particular light. So now, considering 2 different lights, for example, sunlight has different 7 colors with a WebGeo. So considering, for general understanding, considering blue and red as 2 extremities, blue as a light has very less wavelength, right? The wavelength of blue is very less, so hence the scattering is very high. So whenever the wavelength of a particular light or color is less, the intensity of scattering will be very high. So hence the light, especially the blue color, scatters a lot, right? And hence, especially in the afternoon, when the sun is exactly over the head, the sky appears to be blue, because blue, having a very less wavelength, scatters more, and since the sun is exactly above the head, it does not have much distance to travel. So hence, because of the less distance and the huge scattering of the light, the daylight appears to be blue. The same thing on the other hand, the red as a color has the very highest wavelength, right? The wavelength of red color is contrarily very high, which means the scattering is also not that much. So it is inversely proportional. So when the wavelength is very high, scattering is less. So during sunset, when the moon or when the sun is almost near the horizon, right? This is the earth. Now the sun is almost around the horizon. So now for the understanding, now if this is the blue light, this is the red light, right? Blue having a very higher level of wavelength. In fact, the wavelength is 10 times lower than the red light. The wavelength of blue light is 10 times lower than the red light. So hence, this blue light scatters more, right? And obviously doesn't get, will not be visible to the naked eye. And also on the other hand, the same red light, because it is in the horizon, and also since the wavelength of the red as a color is very high, it is the one, that kind of reaches to the normal naked eye of a human being, and they don't scatter more, right? Two main reasons. One is the wavelength is very high. Another important thing is they don't scatter much, considering having a very less wavelength. So this is one of the phenomena you have to keep in mind to understand why the moon, we have seen the recent total lunar eclipse is red in color. So basically what happens when this is the image of the earth completely covering the sun, right? And this is the image from NASA, and as you can see, this is the earth, right? So the earth is completely in front of the earth. It is completely surrounding or blocking the sun's light, and a reddish line or a reddish light is what you can see on the borders or the corners of the earth. So this could be various reasons. One of the reason is the scattering of light, because the red color, the wavelength is very high and it scatters less. And also this is also an indication that either at the places, few of the places can either be witnessing sunrises or also sunsets. That is also one of the reasons. So now this earth, which is exactly in front of the sun, blocking sun's rays, which has to fall on the moon, right, emits or scatters the red light rather than the blue light. So this is the exact image what happens. So now imagine the sun is here and the rays is falling. The blue light, which has very less wavelength, scatters out, and the extreme red, whose wavelength is very high, is the one which directly falls on the moon, giving the moon the color red. So this is exactly how it looks. So now if this is the earth, when the earth comes exactly in between the sun and the moon, so this is how the scattering of the light happens, and this is the red light which scatters less and directly falls on the moon, making it look reddish color. So now I think this is clear. Two things important, keep in mind. One is the scattering of light in terms of the wavelength, and depending on the wavelength, how much of a light can scatter. Can it scatter less or more? And also the most important thing is the Rayleigh scattering as a phenomena or as a concept. So now let's understand what Rayleigh scattering is. So it is a concept introduced by Lord Rayleigh. He was known as John William Strutt, but he was also called as Rayleigh, and he was a Nobel laureate in the 19th century. So he gave the definition. So what is happening? Scattering of light when it interacts with particles smaller than its wavelength, right? Of course, we will not go too much in detail because ultimately it depends, all of this, the Rayleigh scattering, if you try to understand this as a phenomena, has various applications, right? Starting from the lunar eclipse or the total lunar eclipse that we discussed, to all those concepts, like for example, even the usage of red colors, especially to hazard lights, right? Even why do traffic lights, especially the red color, and also why does most of the hazard lights are in the reddish color, and even why is the sky blue, and why is the sunsets red or orangish, right? And even to an extent, why are the clouds white, right? And even why does a beam of light even in a darkest room which has dust will show the beam of the light traveling in it, right? So all of this is the applications of the Rayleigh scattering. So this in itself is another video. Of course, we will not go too much in detail. We have understood sufficiently to understand the total lunar eclipse. So we will just see what Rayleigh scattering is, and that's all, right? So as a definition, it is a scattering of light when it interacts with particles smaller than its wavelength. One of the key points to keep in mind that intensity of scattered light is inversely proportional to its wavelength, and short wavelengths, especially the blue and violet, they scatter more. Example, it explains why the sky is blue. And then long wavelengths like the red and orange passes through and explains the red moon during the eclipse, right? So this is all for this particular video. We have simply tried and understood how the total lunar eclipse happens. So the next time you see a traffic light turning red, or the next time you stop to a stop signal which is red in color, or the next time you enter a dusty room with a torch in your hand and you see the light beam, please remember that is the Rayleigh scattering in effect or in actual presence there, right? So yeah, even before we end the video, let's solve one prelims question. Consider the following statements about a blood moon. It occurs when the moon passes through the Earth's penumbra. Second one, the red color is due to Rayleigh scattering of sunlight in the Earth's atmosphere. Third statement, the moon may appear red, orange or copper depending on atmospheric conditions. Which of the statements given above us are correct? So please use the comment section and also your common sense, right? Try and answer this particular question. And that's all for this particular video. Signing off, this is Madan Gopal. Have a beautiful day.